Hi, I'm Vamshi, and today we are going to discuss about the assignment 2 in machine learning, that is linear models. There are two exercises in this assignment. In the first exercise, we have linear classification, and in the second exercise, we have linear regression. These two are linear models. So first of all, we get into the exercise one. In the exercise one, the first step. The question it has been given that we need to import the necessary packages. Those are matplotlib to plot the uh, figures, plot the figures, and also numpy to make the mathematical calculation, and for the sklearn for data sets, and to train the data and all. And uh, there is also an SDG classifier. It is an inbuilt classifier in the sklearn learning linear model. The so in the first step, you can see we have imported all the necessary packages, and in the second step, we are going to load the diabetes dataset in as we have done in the previous exercise. So first, we need to load the diabetes dataset using dataset.load diabetes, and we're storing the features in the diabetes X and labels in the diabetes Y. So we are checking the we are checking the shape of the dimensions of the diabetes X and diabetes Y. So diabetes X is a 44210, and diabetes Y is 442, and this is the diabetes Y value. And we need to convert this diabetes Y into binary label in order to make this classification suitable for the sklearn. So for that, we have used NumPy mean, so NP mean for calculating the average, and then the average is being used. We have used this average as to determine whether it is -1 or +1. So if the mean is greater than 1, so the value is greater than mean, then we will give 1, and if value is greater than less than the mean, we will give it as -1. So we can you can see here the diabetes Y and diabetes Y binary, and this is the average value. So this is the binary labeled diabetes Y, and then the next step is we need to split the data set into 6:2, 2:2. So where 6 is the training data and 2 is validation, and the next 2 is testing. So for that, initially we're going to so for this we are going to use train test split function, and in that yeah we're going to use a train test split. So in that we're going to get take a temporary splitting temporary size, and in that temporary set in that we take 40%, and then again we will be splitting that temporary set into validation and the testing. So that would be like 6 is to 2 is to 2. So this is the function that this is the code that it going to be running. So we have used inbuilt inbuilt module, like inbuilt function train test split. It will take the x value, y value, uh, x vector, y vector, and the test size, that is 40%, that is 0 0.4, and then random state 42. So we just take that, and then again we need to divide the validation and test from the temporary. So x temporary, y temporary, and then that would be 50-50%, that is 20-20. So overall, we'll get these the dimensions of the x and y, training, testing, and validation. And next, if we need to classify the sklearn, so we need to classify the we need to train the linear classifier using sklearn built-in function. So and then we need to find the coefficients and intercept for that. So for that we are using SGD classifier. That would be training the data set that we have taken. So for that, we are going to use this piece of code in which we have SDG classifier and classifier, and we need to fit the data set. This line going to be training the data set, that is CLF dot fit. CLF is a classifier that we have created where that we are using, and we are going to train using clf.fit, xtrain, and ytrain, which is the training data set. And then we are going to find the coefficient and intercept using the built-in function clf.cof underscore clf.intercept underscore. And then next, we are going to print the shape of the coefficient and intercept. Uh, yeah, this is how we're going to find the coefficient and intercept of the uh, classifier, linear classifier. And then next uh, we are going to implement some utility functions, that is a compute prediction and a compute accuracy for the models that for the model that we have trained. So for that, we are going to define a function called compute prediction, in which so there are two vectors, x vector and coefficient vector, and one intercept is been given. So in that it would be calculating the result. It will be giving a result as an output, which is the the result of the computed prediction. That is prediction value of training data set or testing data set or the validation data set. So this is the formula that using that we are going to find the prediction value, that is numpy dot matrix multiplication of x comma coefficient of transpose, and then we need to add the intercept. So and then we are going to uh, uh, give the binary values according to the decision boundary. Our decision boundary is 1 and -1, as we have already taken the y binary labels as 1 and -1. So the result is greater than 0 1 and less than or equals to 0 -1. So then we need to convert the result into an 1D array. That would be result dot reshape of -1, which is -1 is obviously it says ignore that particular thing. Next, we would be returning the result, that is the predicted value, and then that predicted value would be used for the to compare with the actual value and give the accuracy. So this is the function for that compute accuracy. This is the predicted value, that is the output of compute prediction, and actual value is the y binary value of that particular training data set or that particular data set. And then we would be computing predictions manually, like uh, using this utility functions. We will be computing the prediction prediction of training data set, prediction of validation data set, prediction of test data set, and we will be getting the this we would be taking the dimensions which are one dimensional, and you can see those are 265 to 88, 89. That is the same as so over here, because we are predicting the values of predicting 265 values of the training data set 88 and 89. Then we will be computing the accuracy. For this accuracy, we are going to use the utility function compute accuracy, and in that we would be entering the predicted value of a training data set and the actual value, y train, x train, y train, y value, and y test. So that would be accuracy. We can see we got the accuracy values here. And then now we are using the built-in functions in the sklearn in order to find the prediction and the score, that is accuracy, and we will be comparing with our manually done method. So here are the things. So here are the values that we would be finding. So we would be finding the accuracy. So this accuracy will be, so as we can see, the accuracy values have been matched with the accuracy values that we have all that we have created manually using our own code, that would be matching with the built-in code. So this is the linear classifier, and we have got all these covered in the linear classifier, the coefficient and intercept, and the accuracy values for the data set for the three different data sets: validation, test, and training data set from the diabetes data set. So next exercise is linear regression. In this linear regression, we are not going to use diabetes data set. We are going to generate a data set, and we need to randomly generate the data set using a given using the make generation package, sorry, make generation module function. I'm sorry, function. So we are going to generate x and y values using make generation, and in the question it is mentioned that we need to take n samples, 100 samples, and we do have one feature and noise 10 and random state 42. So and also we need to visualize the data, we need to inspect the data. So for the inspecting data, we are going to use this particular set of code. And then, as usual, we are going to import the sklearn dataset, sklearn.dataset to make generate the dataset for the linear regression, and also for inspecting or for visualizing the dataset. We are going to use matplotlib. So we have implemented the function, and also we got the output as a figure, or it's a plot that would be showing us the 100 samples. And then in the linear regression, we are going to solve it using gradient based so it's also mentioned that we need to solve using gradient based method. So for that, we are going to use the function gradient descent. So for that, we need to in order to implement the gradient descent function, we need to use the gradient one step function inside the gradient descent. So for that, we need to implement two function: gradient descent and gradient one step. So first we would be first we would be defining the gradient one step, which would be taking five values, that is x vector, y value, slope, intercept, and learning rate. So these all values would be initializing the letter. And in this, we are going to find this slope and intercept of the new slope and intercept in each step. So for that, step by step, we would be finding the slope and gradient. So first, slope gradient, we are initializing with 0. Intercept gradient is also 0, and n value is the length of the y, that is the data set we have created, length of the. So in the range of n, that is from I from 0 to n, we are iterating it, and we are finding the slope gradient in each step. And finally, the slope gradient uh, is used to find the new slope, that is the slope that we have given minus learning rate into slope gradient. So learning grade is nothing but how many times that it needs to be incremented. The gradient need to be incremented. So that is the learning rate and the new intercept and all. So it would be returning the new slope and new intercept, this function. So this particular gradient one step would be used inside the uh, gradient descent, that is a slope, initial slope, and this is the uh, pseudocode, that is we need to initialize the slope, intercept, and all, and we need to find the uh, final slope and intercept. So final slope and intercept using gradient descent method. So in this, we would be giving x, y, initial slope, initial intercept, learning rate, number of time that needs need to be iterated, that this particular model needs to be iterated. So here we have taken slope is initial slope, intercept is initial intercept. So in the range of I to the number of iteration time that it's need to be iterated. And we will be finding the slope and intercept using gradient one step algorithm, gradient one step function, or a function which we have been defined previously. In each for every time we will be getting a we would be getting the new slope and new intercept, and till this iteration is completed, till this number of iterations has been completed, then the final slope and intercept would be returned using this function, returned in this function. So for that, we are implementing the using initializing we are initializing the these particular parameters in order to implement the functions that we have defined, and these are the learning rate 0.01, and initial step is 0, initial intercept 0, and number of iterations of 1000. So according to the question, that's the thing. And then next slope intercept we would be finding using gradient descent from gradient descent. So we would be finding the gradient uh, slope and intercept using gradient descent function. That we would be giving all these parameters and x and y values that we have generated in using make generation make regression function. And the next we are going to plot the plot the uh, a given data set, given generated data, and also we are going to plot the fitted line for the for that particular data. So this is the this is the label, so that one, and this is the line that we are taking. So for this line, this x values are x values, and the y values is nothing but a linear line, that is slope into x plus intercept, that is equals to, so theta x plus theta naught. That would be more easier, where theta is slope and theta naught is intercept. So the same way, slope into x plus intercept is the y value. X and y values are given, and we are finding the slope intercept. So this is the fitted line. Uh, this is the end of the assignment. So thank you.